Hello, friends. I welcome you to all on my channel. Now, as you all have requested to make video on mechanical topics, today we will discuss a topic which is from theory of machine subject. And after this topic, we will cover dynamic analysis of slider crank mechanism. But since we need this topic for dynamic analysis, so we will discuss or start our topic kinematic analysis of slider crank mechanism. So before starting this video, please I request you all to please like. If you really like this video, like, share with your friends and subscribe below the bell icon, please, so that I will get motivated and make more videos on mechanical topics. Thank you. Now let's start. Now this is our engine cylinder, and it is piston inside the cylinder. Now this is a connecting rod, and this is a crank. Now this end, which is known as rod or crank end, is in front of crank side, that's why we call it crank end, and this one is cover end. This is engine cylinder, as I have told you earlier, and this is this link between piston and connecting rod. There is a pin, we call it a cousin pin, and this is connecting rod, and this is crank. Let us suppose it is rotating with omega angular velocity. We will discuss all the terms related to this. Now it is the rough, I have drawn this rough path along which crank will rotate, as crank length will be the radius of this circle. It rotates in a circular path, and this is inner dead center, and this is top dead center. Inner dead center is also known as bottom dead center if we will consider the vertical engine. Since we have considered it as horizontal, so I have written inner dead center. Now this angle is theta, and this angle is beta. Observe carefully, the angle theta and angle beta have its direction from top dead center or inner dead center. Okay, clockwise is theta direction, and anti-clockwise is beta direction. So always we will take the direction or sense of theta in from inner dead center or top dead center. Now the terms related to this topic is m is mass for all the reciprocating parts. Here we have r is the radius of crank. Length of crank is r, and L denotes the length of connecting rod. Now theta denotes the angle turned by the crank from inner dead center or top dead center. You see the dotted horizontal line I have drawn in the last figure. We have to take the theta from that position or that straight line, dotted line, inner dead center or top dead center. Okay, our analysis is based on direction. So if we take another direction, or we will take the theta from other direction, then we will get the wrong answer. So just be cautious about that. Now omega is the angular velocity of crank. It is also defined as rate of change of angular displacement or theta with respect to time. Now we will define a term that is obliquity ratio. Obliquity ratio, I will denote it with n. Now n is equals to L by R. L is the length of connecting rod, you all know, and R is the radius of crank, or say length of crank radius. Now this value will be always larger value. Keep in mind, it will be larger value. Now if in question it is given n is equals to, let's say, just keep in mind n is equals to L by R. Obliquity ratio is always greater than 1. Okay, now if in question we have been given n is equals to, let's say, 0.6, so we have to take the larger value, that is n is equals to 1 by 0.6, that is 10 by 6, or we can say 1.66. This is our obliquity ratio. So keep in mind, always be cautious with the value of n, obliquity ratio. No, because some textbooks refer that n obliquity ratio is R by L. So due to this confusion in numerical problems, we may have confusion and we may get a wrong answer. So always keep in mind, I have derived this equation, or in future I will derive every question with n has a larger value, that is L by R. Its ratio is L by R, larger value. Now this is a piston arrangement, piston crank arrangement, and now this is beta and this is theta. Beta is the angle made by the crank from inner dead center. Beta is the angle of a connecting rod. Now beta is the angle made by the connecting rod, and theta is the angle made by the crank with inner or top dead center. Now let us say this point, the cylinder head topmost point, we will denote it as A, and the Gaussian pin, the point Gaussian pin, let us call it at B. Now we will define a axis, this is y axis, this is x axis, and now we will take the displacement of piston as we measure the distance x towards x axis from A. Now let us find out the value of L sine theta B. See, let us draw the perpendicular on this line, and the component of connecting rod length on x axis is L cos beta, and on y axis is L sine beta. So the value of L sine beta will be equal to, now see in other triangle, this value will be equal to this value, okay, the perpendicular length, because the same triangle we have found the component of that hypotenuse. Now OA is same as equal to this component R, crank radius component on x-axis will be r cos theta, so this OA will be same as r sin theta. So L sin theta, L sin beta is equals to OA, that is equals to r sin beta, r sin theta, sorry. So from here we will calculate sin beta. Sin beta is equals to r sin theta divided by L. Now see, we can see this L by R ratio as n. So we will write sin beta is equals to sin theta upon n. Okay, now since cos beta is equals to root under 1 minus sin square beta. Okay, let's go from basic. Cos beta is equals to root under 1 minus sin square beta. So that implies root under 1 minus sin beta, we got the value here, sin theta by n. So sin theta by n whole square. Now that is will be equals to 1 square minus 1 minus sin square theta by n square, and when we will take the LCM, we will get root under n square minus sin square theta divided by n square. So cos beta is basically equal to root under n square minus sin square theta divided by n. I have taken n, I have taken out n from root, outside from the root. Okay, now first we will see the piston motion. Okay, our first analysis will be on piston motion. Now first we have to find out the displacement. We have to find out the displacement of a piston, that how much piston is displaced at any angle theta, or in problem we will be given length of connecting rod, length of crank, and theta or beta, any angle from inner dead or top dead center, or if it is not given theta from inner dead or top dead, we will convert it from inner dead or top dead center. Now displacement x is equals to, we have taken this axis, so x from A. Now x is the displacement, how much piston has displaced. This is the value AB. The piston has displaced from top dead center to AB, so AB is the displacement. So AB will be equals to AC minus BC. Now x is equals to AC. What is the value of AC? AC is nothing but the when the piston is at top dead center. Now the length of connecting rod and the length of crank will add up to the value AC. Okay, from here to here. See, let us suppose piston is here. Okay, so from here it is in the mid, it is connecting rod, and after that it is crank. So the x value will be equals to AC minus BC, and AC is L plus R, since it's the top dead center. Now BC is equals to inner dead center or bottom dead center. So this will be we have drawn the perpendicular from that, so it is L cos beta. In the previous figure we have drawn L cos beta, the x-axis component of connecting rod, and L cos theta, that is x component of crank. So this will be BC will be L cos beta plus R cos theta. Now we will simplify this. X is equals to, put the value of uh, L in terms of obliquity ratio. So N is equals to L by R. So L is equals to N into R, obliquity ratio. Okay. Now R plus NR minus L cos beta. Cos beta will be equals to, we have found n square minus sin square theta divided by n square. We have taken n in inside the root, so we have taken n square. Now plus r cos theta. Okay. Now simplify this. So we will get x is equals to, now take n L as nr. Okay, change it to nr, obliquity ratio. Now when we take out the n from root outside, n square, it will become n, and n will be cancelled out. So r 1 plus n, r we have taken common, nr upon n, root under n square minus sin square theta plus r cos theta. Now n cancelled out, so we will get x, take r common from whole terms, 1 plus n minus root under n square minus sin square theta plus cos theta. Now since we have done something wrong, we would have been taken the whole common, so this will be whole big bracket and big bracket. Now let us rough the whole thing. Now take r common, and so now we will get the value of x is equals to r taken whole common, 1 plus n minus root under n square minus sin square theta. So sorry, we have taken r as common as whole, so now root under n square minus sin square theta plus r we have taken common, so minus cos theta only. Now x, we will simplify this and we will get x is equals to r 1 minus cos theta, and here we get n minus root under n square minus sin square theta. Okay. Now this is right. Okay, now this is the expression for displacement, that is how much piston has been displaced, and this is the this is the crank radius, crank radius, and this is theta. Theta is the angle turned by the crank from inner or top dead center. Please be cautious, I am repeating, be cautious taking theta only from the top dead center or inner dead center. Okay. Now n is you all know obliquity ratio. So here obliquity ratio will be always greater than 1 or larger value. Now we can see here that in question, if crank radius is given, length of connecting rod is given, and theta, that is angle from the inner dead center or angle at which we have to find out that how much piston has been displaced by rotating the crank from the theta angle, we can find out the displacement easily. Okay, thanks for watching. Please like, subscribe if you like